Welcome to Spring LIB.
The given vectors are A and B. A is vertically downwards and is 8 units long, and B is 15 units long and makes an angle 30 degrees east to north, which is with the positive y-axis. Now, if we choose our x-axis to be horizontal and y-axis as vertical as usual, we can see that vector A would be minus 8 j cap because it is completely vertical but is in downward direction, which would be minus y direction, hence minus 8 j cap. And B would be, because it makes an angle 60 degrees with x-axis, we can write it as 15 cos 60 x I cap plus 15 sine 60 j cap. By plugging this into a calculator, we can see that it is 7.5 I cap plus 13 j cap. Now, for part A, we need to find A plus B. Now, we know that when we add two vectors, we add their components, their individual components separately. So here, because it is just minus 8j, A is just minus 8j, we can write it as plus 0 I cap. That is, its x component is 0. Hence, by adding their two x components, we can write it as 0 plus 7.5 I cap plus minus 8 plus 13 j cap, because these two are the y components of A and B. Now, 0 plus 7.5 gives us 7.5 I cap plus 5 j cap. This is our A plus B. Now we can find out its magnitude using Pythagoras theorem. It would be the square root of the sums of the squares of the individual components, and that would be 5 square plus 7.5 square under root square whole root, which turns out to be, if you put it in a calculator, almost 9 units. Now, the angle it makes with the x-axis would be tan inverse of the y component, which would be 5, divided by the x component, which is 7.5, which turns out to be 33.7 degrees. This would make sense because if you see that our vector A plus B is 7.5 I plus 5j, we would expect it to look something like this. And hence this angle would be about 33 degrees. Now let's go to part B. Part B is finding the vector B plus A. Now we do the same thing again. We add the individual components. We know that B's x component is 7.5 and A's x component is 0. Then we multiply with an I cap. Now we add the j components. We know that B's j component is 13 and A's j component is minus 8. Then we multiply with j cap. Now this again turns out to be 7.5 I cap plus 5 j cap. We know that vector addition is commutative, and we've showed this here. Now, as usual, because this vector is the same as the last vector, its length would be the same as the last one, which would be the square root of 7.5 squared plus 5 squared, which would be 9. And the angle it makes with x-axis would be tan inverse of y component divided by the x component, which would be 33.7 degrees. This vector would also look something like this, which is the same as the last vector. Now, for part C, we need to find A minus B. Now we do the same thing again. We subtract the individual components this time. So we know that the x component of A is 0 and the y component of B is 7.5. So we subtract that from 0. And the j component of A was minus 8 and the j component of B was 13. So we subtract that and we get minus 7.5 I cap plus, minus 21 j cap. Now we know that this vector lies in the fourth quadrant because both of its components are negative. Now we can find the angle it makes with x-axis theta, which would be tan inverse of the y component divided by x component, which is 21 by 7.5, which turns out to be 70.4 degrees. And the length of this vector would be the square root of the sums of the squares of the individual components, which would be 7.5 squared plus 21 squared, which turns out to be 22.3 units. Now, the fourth part is finding b minus a. So we do the same thing as before, but this time we subtract components of a from components of b. We know that b's x component is 7.5 and a's x component is 0, I cap. Now we know that b's x component is 13 and a's x component is minus 8. So minus of my two minuses become a plus, and this turns out to be 7.5 I cap plus 21 j cap. You might note that this is equal to minus a minus b, which we would expect due to scalar multiplication of vectors. Now this vector would have the same magnitude as the previous vector because the signs of the individual components don't matter when you square them. The magnitude of this vector would again be 7.5 squared plus 21 squared whole power half, which is the whole root, and that would again be 22.3 degrees. 22.3 units. But this vector, instead of being in the third quadrant, would be in the first quadrant. I said the previous vector was in the vector a minus b was in the fourth quadrant, but this is actually the third quadrant. This is the fourth quadrant. Now, going back, this vector, because it has positive x and y components, would lie in the first quadrant, and the angle it makes with x-axis can again be found out as tan inverse of y component divided by x component, which are 21 divided by 7.5, which again turns out to be 70.4 degrees. That's it.